Hello and welcome back. Today we will discuss about Lakeflow Spark Declarative Pipelines. Now, before we can start with Lakeflow Spark Declarative Pipelines, or in short form which is known as SDP, let's first understand what exactly is this Lakeflow. Now, if I look at the documentation that has been provided by Databricks, Lakeflow is a unified data engineering solution for data ingestion, transformation, and orchestration. Now, it is not that Lakeflow is something new to Databricks. It was already there, but now it has been rebranded properly and it has all been put under the same umbrella, which is Lakeflow. So, Lakeflow consists of three portions. The first one is ingestion, which has been taken care by Lakeflow Connect, which helps you to bring data from external systems onto your Databricks platform. The second one is data transformation, which will be taken care by the declarative pipelines, which are Lakeflow Spark Declarative Pipelines, or in short form SDP. And the third one is orchestration, which will be taken care by Lakeflow jobs, which were earlier known as workflows. So now you understand what is Lakeflow on Databricks. It is a unified data engineering solution now where you can ingest, transform, or orchestrate your data or data pipelines. Today, we will understand what exactly is Lakeflow Spark Declarative Pipeline. So if I quickly go back to the documentation, if I scroll down, Lakeflow Spark Declarative Pipeline is a declarative framework for developing and running batch and streaming data pipelines in SQL and Python. Now, if you remember, this was already there on Databricks and it was known as Delta Life Tables, which was known as DLT. So why this change? Why do we need Lakeflow Spark Declarative Pipeline now in place of DLT? So there's one more documentation that Databricks provide. What happened to Delta Life Tables, which is DLT? So if you look into this document, the very first line tells you the product was formerly known as DLT or Delta Life Tables, which has been updated to Lakeflow Spark Declarative Pipelines, or in short form, it will be known as SDP. Now, why this has been done? This has been done because declarative pipelines were open sourced in the last Data and AI Summit by Databricks. And it will be available with Apache Spark starting 4.1 and which will be known as Apache Spark Declarative Pipelines. So, in order to introduce compatibility between the declarative pipelines which are available in Databricks and the Apache Spark Declarative Pipelines, DLT was rebranded and updated to Lakeflow Spark Declarative Pipeline with few minor changes and with a lot of new enhancements. Now, does this mean that whatever code we have written previously for DLT and the core concepts of DLT will change? The answer is no. The code, whatever we have written for DLT, will still continue to work on Databricks, but the recommendation from Databricks is to use declarative pipelines going forward. So, whatever core concepts that we learned for DLT will still hold true for declarative pipelines. And the code that we have written for DLT will still work on Databricks. But if you want to write the new code using declarative pipelines, there will be a few minor changes that you need to do. And today we will see all of this with demo. Now, before I can start with that video, if you have not seen our previous video on Delta Life Tables, I would recommend you to go back and watch those videos first, because without those core concepts, it is difficult to understand Spark declarative pipelines. Now, before I show you all of that with demo, let me show you one more page. So if I scroll down the same page, you can see here a hyperlink saying what happened to @DLT. If I go into this page, here in this document, you can find all of the comparative changes between DLT and SDP, along with what is available in Apache Spark and what is only native to Databricks. So now that I have given you enough context about it, if you have not subscribed to this channel and not watched the previous videos, go ahead and watch them first. Now, without any further delay, let's go ahead and start with the demo. I am back in my Databricks workspace. Now, today to write our declarative pipeline, we are going to use a new code editor which is now available with Databricks. In order to enable that code editor, you first need to go to the profile icon on the right hand top, click on Previews, search for Lakeflow, and you have to enable Lakeflow Pipeline Editor. You have to make sure that this is on. Now we can use the new pipeline editor which is available in Databricks. Now, in order to open that editor and create our first pipeline, we just need to go back to Jobs and Pipelines, and we have to click on this button which says Create. Now here you can see three things. The first one is Jobs. which is actually our Lakeflow jobs. The second one is ETL pipelines, which is our Lakeflow Spark Declarative Pipelines or SDP. And the third one is ingestion pipeline, which is our Lakeflow Connect. Now we already know the difference between all these three. Today we are going to work with ETL pipeline. So once I click on this, you will be on a page where you can start configuring your pipeline. Now I'm going to put some examples from our previous code that we have written for DLT. If you have not watched those videos, go ahead and watch those videos first. Now, I've named this pipeline as Lakeflow SDP. This is for Lakeflow Spark Declarative Pipeline. Okay, once I've done that, I have to select a catalog and a schema. I'm going to select a catalog which is dev, and I'm going to create a new schema. So I'll click on the drop down, I'll click on create schema, and I'll provide the name as SDP. Okay, so this would be the new schema. Now, if you click on this drop down, you can just turn off this toggle to go back to the legacy way of creating your pipelines, where you can just go ahead and write your notebook and configure them as ETL pipelines. But I'll recommend you to go ahead and use this new editor because it is quite intuitive and it is very easy to use. So we'll let it be on. Okay. Now you get certain options like you can get started with SQL, Python using some sample codes, or you can even start with empty files. Now today we will write our pipeline in Python using some samples. So I'll just click on start with sample code in Python. Now, once I do that, you can see a lot of stuff on my screen right now. So let me just quickly close on the left hand side. And now let me just zoom in a bit. Now you can see a lot of stuff on my screen, right? On the left hand side, you can see a lot of artifacts. In the middle, you can see a pane. And on the right side, you can see a pipeline graph tab, right? So let me explain what all this is. So on the left hand side, you can find all the assets for your declarative pipeline. In the middle, you will write your code. This would be your code editor. And on the right hand side, you can see the graph that would be generated for your pipeline. Okay. In the bottom, you can find the tables and the performance and the information about the assets or the data assets that you create with this pipeline. We will see all of this today, so you don't need to worry about it right now. So let me just close this from here. Great. On the left hand side of the code editor, you can see all of the pipeline assets that would be required for your ETL pipeline. And we will explore all of them in a moment. But before that, let me show you the pipeline configuration. So on the top, you can see some option called pipeline configuration, from where you can configure what compute to use, what would be your path, and all sort of stuff. For that, you can go ahead and click on this settings button, or you can also click settings from here. Also, there is a button called schedule that you can use in order to schedule your pipelines. The same option is also available here on the top. Now, if you want to change the configuration for your pipeline, you can just go ahead and click on here on the settings, and you can very well use this pane in order to change your settings. Now, if you don't like this new UI for the changes that you want to make for your ETL pipeline, you can very well go back to the legacy pipeline settings. Once you click on this, it will open the old UI for the ETL pipelines that we used when we configured DLT pipelines. So it will open the same UI. But if you notice here, this is much more easy to understand. So here at the top, you see the pipeline ID, the pipeline type, and who is the owner of this and who can run this, right? Here is where you can find all of the folders that you can attach for your code assets. Now, this is similar to the DLT pipeline that we had in the legacy system, right? Where you can provide the notebook files and all. Here, you can directly provide the folders. And within that folder, everything would be considered as the code asset for your ETL pipeline. Now you can configure path using this button. Again, you can change the catalog and the schema from here. Also, you can configure the compute. So if I click on edit compute configuration, you can enable serverless from here, or even you can change the product edition. And also you can change the number of workers, and also in the advanced setting, you can change the worker type. So this is similar to what we used to do in legacy, right? So let me just click on cancel. And if I scroll down here, you can also add configurations. So if you remember, in our legacy settings, we can pass key value pairs inside our DLT pipeline. This is the same thing. Okay. And if I scroll down in the advanced setting, you can see the channel, which is current. And also, if you want to publish your event logs to catalog, you can very well change this from here. Okay. Now, if you want to see all of this in the same legacy setting, you can just go back and click on legacy pipeline setting, and this will open the legacy settings that we used to do for our DLT. And this is the same settings. Okay. So let me just go back again. And now you can very well correlate the new settings UI with the legacy one. Okay, so let me just close this from here. Now that we understand how you can change the settings for your SDP pipelines, Let's understand how you can configure pipeline assets. On the left hand side, you can see a lot of folders here. So let me just close all of them first. And now if you notice, Lakeflow SDP is our root folder, or you can say the parent folder. There are some three dots that you can click, and you can very well change the name of your root folder if you wish. You can even move it to some different root folder, or you can configure a new root folder here. Even you can change permissions to this particular root folder from here. So there are a lot of settings that you can find here. Now, below this folder, you can find three more folders. The first one is exploration, the second one is transformations, and the third one are utilities. Now, if I expand the exploration, under this you can find a sample notebook. Now, exploration folder, which has been provided in our sample pipeline, is optional. You can very well keep this folder or remove it because this folder is not part of your pipeline execution. So if I click on the settings button from here, if you notice here, your source code lies in transformations folder only, right? There is no exploration folder here. So whatever code that will be below this exploration folder will not be part of pipeline execution. Now, if you notice here, that has been represented with this symbol here. So let me just zoom in a bit for you, and you can see a link symbol which is disabled from here. Now, in the second folder, in the transformations, you can very well find the source code, which is included as a part of your pipeline configuration. Okay, so that we can very well see from the settings. So if I click on the settings, you can see transformations, right? So whatever code we put below this particular folder will get executed as part of this pipeline execution. Now, you can very well add or remove code for execution, right? For example, if you want to add the exploration part itself as part of pipeline configuration, you can just click on this three dot and say include folder as pipeline source code. Once you do that, it will be included as part of your source code. It means as soon as your pipeline runs, all of the code within this particular folder will also get executed. But this is a sample exploration notebook. Exploration means this will be used in order to see your data assets or validate your data assets. This should not be executed as part of your pipeline, right? So this is why this has been excluded from your pipeline execution. Now, in transformations, you can see this has already been included. So you can very well exclude the whole folder, or you can exclude a particular file as well. For example, if I don't want this file to execute, I can very well exclude this. But since the parent folder itself is included, this is why all the files will by default be included. Now, if you don't want any of this file to be executed or to be excluded from pipeline execution, just remove this from this folder and put it in explorations. This will not get executed. Okay, so this was transformations, and the third one is utilities. Again, you can see this has been disabled and this is not part of pipeline executions. Rather, this has been added, and this is again optional. The utils.py will have some code which will be supportive for your pipeline execution code. For example, there is a UDF defined in this, right? So our code will get executed from here only, which is transformations. So now you understand what are the three different folders that has been provided with our sample. Now again, explorations and utilities are optional. You can very well remove those and only keep the transformations as your pipeline code. That would again work. But it is a good practice to create different folder structures and organize it as per your requirement. Now, if you want to add any new folder that has to be included as your pipeline execution, you can very well click here and you can say create, and you can create a new folder. For example, I'll just add one folder, say XYZ, and you can include this folder as a part of your pipeline execution. You can just click on the three dots. You can click include this folder as pipeline source code. Once you do that, if you go to settings, and you can see along with transformations, XYZ is now also part, and any file that you put under this would also get executed. So now you understand how you can very well configure your pipeline assets from here, right? So let's do one thing. Let's go ahead and write the same code that we have written in our previous session of our DLT, right? So we are going to bring in some of the DLT code and we are going to convert it for declarative pipelines. And in order to do that, what I'll do is I'll quickly remove this folder from the pipeline source execution. So now you can see the icons has changed. Now these are no longer part of source execution. You can very well validate. You can go to settings and you can see transformation is no longer part of execution, right? Now we have any code that we'll write under XYZ. So I'll just rename this folder again. I'll change it to say orders pipeline. Okay. This will contain all of our source code that we have written previously, and we'll write those as declarative pipelines. So what I'll do is I'll click here. I'll say create file. and I'll give it name as orders.py. Okay, and this will be a Python file here, and this would be part of our execution now. Now, in order to get started with declarative pipelines or SDP, now we need to use pipelines from our PySpark module. So for that, we will do from PySpark import pipelines, and we are going to alias this as DP, which stands for declarative pipeline. Okay, you can name it as anything as you wish, but we are going to use DP for now. Okay, now the first thing that I'll do is I'll paste some code that we have written previously in DLT, and we are going to convert it for SDP. Now, this was the code that we have written previously for DLT, right? You can very well see it says at the DLT.table, and the table properties, it was quality bronze. There was a comment, and then there was a function defined orders bronze, right? So the name of our table was orders bronze. So let's do one thing. Let's change this. So in order to change this, we have to do nothing. Rather, in place of DLT, we have to say DP. Okay. So dp.table would create streaming tables. Okay. So now this has been converted for SDP. This was the only change that you needed to do. Now let's create one more for our customers. So for that, again, I'll create a new file here. I'll say customers.py. Now, my sole purpose here is to show you that you can write your pipeline with multiple files. You can even write all of your code within the same file, but let's break it into multiple files. So I'm going to write the customer code here in customers.py. So again, I'm going to paste the code that we have written previously for DLT. But before that, let me just import pipelines. Now here we are going to create a materialized view. Now you can still use dp.table in order to create materialized view because we are using a batch mode of read, which is dot read. Now if you notice here, we have used dot read stream. This is why it was a streaming table. Now here we are using a batch mode dot read. This is why this would be a materialized view. But in SDP, there is one more neat way. Rather than using table, you can very well say, okay, so you can say dp.materialized view, and this will create a materialized view. But you have to make sure that you are still using .read, which is the batch mode that we know from our DLT course, right? We know that in order to create streaming tables, we use read stream, but we use the batch mode in order to create materialized view. And now you can see this code would create a materialized view that would be our customer bronze. And now if you notice, this was such a small change that we had to do in form of syntax to convert our existing DLT code in Spark declarative pipelines, right? So we have very well created a streaming table, which is orders branch, and we have created a materialized view called customer branch. Let's go ahead and create a SCD type 2 table for our customer, and we used apply changes previously for that. Now apply changes has also been rebranded as AUTO CDC. So that's a very small change. We have to change the name for it. Okay, so we are going to do that. But before that, in order to create a SCD type 2 using apply changes, we need a streaming view or a streaming table. So let me just create a streaming view from our customer branch first. So in order to do that, I'll again paste the code from our DLT code. So now if you notice, this was the code that we have written previously in order to create view. Now, first I'll change the DLT to DP because now we are using DP. Okay, so this will create a temporary view for your pipeline, but it will not create a persistence view. So we will create a customer bronze view from our customers raw. And we are going to use read stream for this in order to make sure this is a streaming view. Now that our view is created, let's go ahead and write our code in order to create a SCD type 2 table for our customer. Now, previously we used apply changes for it. So let me just first paste the code here. So this was our previous code where we used apply changes in order to create our SCD type 2 table, right? And we used DLT for it. Right now we will use DP. So I'll say DP dot, and again I'll change it to DP dot. Okay, now create streaming table would still remain same because there is no change for it, but in place of apply changes, we are going to use auto CDC. So if I quickly go back to the documentation where we have seen the comparison, and if I scroll down here, you can very well see here, it says apply changes. This has been renamed to create auto CDC flow. So I'll just copy this from here and I'll change the apply changes to create auto CDC flow. Okay, so again, apply changes has been rebranded to create auto CDC flow. Rest of the code, whatever we have written previously, will still remain same. There is no change for it. So in this file, we have first created our customer bronze materialized view. Then we have created a temporary view from our customer bronze. So let me just copy customer bronze from here and we will do it from customer bronze. Now, one thing to notice here, there is no need of using live now. We don't need to write live dot. Okay. Now it is wise enough to understand that it has to use the same table that has been created within this pipeline. Okay. So you don't need to use it anymore. So we are going to create a temporary view which would read the data from our customer bronze materialized view. And then we are going to create a SCD type 2 table from our customer bronze view, and the name of the table would be customer SCD bronze. And we are using create auto CDC flow for it. And we have listed this as SCD type 2. Okay, so our code for customer is complete. Again, I'll go back to orders and now I'll write a join between orders and customer. Again, this would be the same code that we have written previously. So this was the code that we have written previously in order to create a joined view. Okay, so I'll again change the DLT to DP. Okay, and now if you notice here, we are using live notations. Now live notations are no longer mandatory. So I'll just remove the live notations from here. And also we are not importing it from orders union bronze anymore. We are using orders bronze. So I'll just copy it from here and I'll paste it here. Okay, and we are doing a left outer join on this. Now this is going to create a view for us, but we don't need a view today. Rather, we'll write it to a materialized view. So I'll just say materialized view. Okay, so we are going to create a materialized view called join view. So let me just change the name here. So I'll make it orders customer joined. Okay, so this would be the name of our materialized view. We will join the SCD type 2 customer table and the orders branch. So our code is almost complete. But before I run this code, let me show you one more thing. Today we will add something called a sync. Now sync is something where you can write the data from your SDP pipelines. Now you can write the data into a delta table, not a delta live table, rather a delta table if you wish. And you can also write your data to Kafka as sync. Okay, sync is your target. So today we are going to create a sync as a delta table itself. So what we are going to do is we're going to click on this three dot. I'm going to create a file and now I'll change the data set as sync here. Okay. And I'll just name it as delta sync.py and I'll click on create here. As soon as I do that, it will create a new Python file. But if you notice here, it has already given me the code that it would use in order to create a sync. Now, let me just remove the spaces from here. So I'll just clean it up a bit here. And now if you notice, the code is dp.createSync and the name of the sync is delta sync. The format is delta. And here we are specifying where it has to write. It is going to write in a delta table in the dev catalog SDP schema and the name of the table is delta sync. So I'll let it be whatever it is. Okay. Now, in order to write into a sync, we first need to create an append flow. Now we have already discussed how to create append flow in our DLT, right? So this append flow is going to use the same delta sync as target. Okay. And now within the function append to delta, we are going to read the materialized view that we have just created. Okay. So I'll go to orders here. I'll copy the name from here. I'll go back to delta sync and I'll paste the name here. So once our orders and customer are joined into this particular materialized view, we are going to dump the data from materialized view into a particular delta table where the catalog is dev, the schema is SDP, and let me just change the name as orders customer delta sync. Okay, so this would be the name of the table. So now that our code is ready, let's go ahead and run this pipeline. And let me just zoom out a bit. And in order to run this, first we need to change the compute setting. So I'll click on settings here, I'll scroll down and I'll click on edit compute configuration. Now I'm not going to use the classic SDP configurations. Rather today I'm going to use serverless. So I'll just click on serverless here. I'll click on save. Okay. And I'll cross it from here. And now our code and the pipeline setting is ready. Let's go ahead and run this. Now, before I run this, let me do a dry run in order to see if everything is working out or not. As soon as I click here, you can see in the bottom, it is showing me the progress. On the left hand side, you can see all of the runs. Now, if you want to see this on the monitoring tab, just click here and it will open the monitoring UI here. Okay. Now, if you want to change it back to the old monitoring UI, you can just turn off this toggle from here. But now if you notice here, our run is complete and we can very well see the complete graph here, right? So customer bronze, we are creating a view, then we are creating a SCD type, then we are reading the orders bronze, joining it as materialized view, and then we are writing it in a sync here. Okay. So our code is working fine. So let me go back to the UI. And we can also see the same run from here as well. We can just click here and we can also see the pipeline graph from here. If I click the maximize button here, you can very well see the same graph from here. So let me just close it. And now that our code is ready and everything is working out, let's go ahead and run it. So I'll just click on run pipelines and we are going to monitor it from here only. And now you can see all of the tables that will get created with this pipeline and the type of tables as well, right? So if I expand here, the type of tables, and here the name of all the tables. Okay, so I'll just wait for this to complete. On the left hand side, if I click here, you can very well see the graph here. So I'll just click on maximized, close this, and you can see the run here as well. Okay, so it has already read 300K records for customer bronze. Streaming table 300K records, 7.5 million in orders bronze. Now it is joining the data set here. Great, 7.5 million in the joint data set. And you can see 7.5 million it has written into our delta table as well. So let's get into catalog and verify. So I'll quickly open the catalog in a new tab. So I'll just duplicate this tab. I'll go to catalogs from here and I'll expand the dev. I'll expand the SDP from here. And now you can very well see all of the assets that has been created. But now if you notice, orders customer delta sync is a delta table. Okay, it's not a materialized view, it's not a streaming table, rather it's a delta table itself. Okay, and that to a managed delta table. Okay, and rest others you can see here created. Okay, so I'll quickly go back to the code. Great, now that our code execution is complete, you can very well understand how you can write SDP code in the new editor, right? Let me show you a few more things. In the bottom, if I expand it from here, you can find a lot of details about the data sets that has been created, right? And the number of records that has been written, the output records and the updated records, all sort of information is available here. Okay. Other than this, you can go to performance and you can see all of the queries that has been fired. And if you click on this queries, you can very well see the complete query profile right here from the editor. Okay. So that you understand what is happening in the background. I'll just close it from here. So you can very well see the performance right here from the code editor. Other than that, you can go back to the monitoring tab. And if you scroll on the right hand side, you can see all of the event logs as well. So if I click here, you can see all of the event logs that are created as a part of this pipeline refresh. Let me show you one more thing. If you click in any of the table, you can very well explore everything about that particular data set right here in the bottom. For example, I've clicked on customer SCD2 bronze and I can see all the data for that particular table. Now, if you want to refresh that particular data set, you can very well click here, refresh, and even you can run a full refresh right here from the bottom. Okay. Also, if you click here on the columns, you can see all the information about the columns for that particular data set. Other than that, you have table metrics plus performance of the refresh. So if you click on any of the data set right here, you can very well see all of the information about the data set. So you can very well explore everything right here in the bottom pane. Again, if you don't want to do that from here, you can very well use the exploration notebook that was created, right? You can click here on the notebook. Let me just close the graph and you can very well say select star from, and you can very well say dev dot sdp dot, and you can see customer SCD2 branch. Okay, you can run it and you can very well explore the data right here in this notebook, and this notebook will not get executed as a part of your pipeline. Now if you want to delete this pipeline, just click on this three dots here on the pipeline configuration, click on delete pipeline. As soon as you delete the pipeline, all of the artifacts that has been created as a part of this particular pipeline. When I say artifacts, means the data sets like materialized view, streaming tables, or the views or the temporary views, right? So if I click on delete pipeline, everything would be gone except the sync that we have created. The sync was a delta table, right? So it will not get dropped. So let me just click on this delete pipeline from here. So as soon as I do, you can see the pipeline is gone from here, right? So let me just go back to the catalog. Now you can see all of this here. Let me just refresh. And now you can see everything is gone except the delta table that we created as a part of sync. But if I go to workspace, that particular folder which we have created in order to write our code is still there. That is not deleted. Only our pipeline is deleted. So if you want to create that pipeline back, what we need to do is we have to go back to jobs and pipelines. We have to click on create. I will select ETL pipeline here. I'll just give the name again, for example, Lakeflow SDP. I'll select the catalog, which is dev, which is SDP, and I'll select add existing assets because we already have that code written, right? So I'll click here. Now it says root folder. So I'll just go here. I'll select Lakeflow SDP, which is the root folder. Now, where is our source code? I'll just select orders pipeline because all of our source code is within this particular folder, and I'll click on add. As soon as I do that, you can still get back all of the code that you have written as part of this pipeline. But the data assets will be gone, except the sync that you have created, which was a delta table. Now, before I wrap up, there is one more thing left, which is default publishing mode. So if you notice here, whatever tables we have created, for example, customer bronze or customer bronze view or create auto CDC flow, right? Everything was created in dev SDP, right? It was created in catalog dev and schema SDP. So previously we didn't had an option to write any of the data set outside the default folder. Now you can do that using default publishing mode. So for example, if you don't want to write customer branch in dev SDP, rather you want to write in a different catalog or schema, what you can do is within this DP Materialized view, you can give it a name, and the name would be 3-level namespace. So you can provide like dev dot default, and you can give it name like orders raw. Okay, so now if I run this, it is going to create a materialized view at this location, not in dev SDP. Okay, so this is default publishing mode. Now you can write your materialized view and streaming tables in different catalogs and schemas from the same pipeline. It is not mandatory that you have to write all of your materialized view and streaming table within the same catalog and schema which was selected for execution. The only thing you need to do is you need to provide the name in the form of 3-level namespace. Great. There's one more thing that I want to share is if you want to write your DLT pipeline in SQL code along with this particular Python code, you can do that as well. For example, I can just go ahead and create a file here. I can say SQL. I just give it a name, for example, MB SQL, and I select, for example, materialized view, and I click on create. It is going to create a sample for me. So for example, you can see it has written a code in SQL in order to create a materialized view MB SQL. Now you can use this MB SQL materialized view in your Python code as well. I'll go to customers py, and what I'll do is I'll immediately create a materialized view from it. So what I'll do is I'll say dp dot. So what it would do is it would create another materialized view in the Python code using the materialized view that we have created in SQL. So let me just quickly configure the pipeline settings. So I'll just go to settings here, and you can see it is still serverless, so we can very well do a dry run. So I'll click here on the drop down and I'll click on dry run. So it is running here. So let's just wait for it. Awesome. The dry run has completed. So let me just expand the pipeline from here. I'll do a maximized here. And now if you notice here, we are using the materialized view, which was written in SQL in Python. Okay, so we have created a materialized view in Python code that is using the materialized view which was written in SQL code. So you can understand now that you can very well write SQL code or Python code both here. Okay, and that is interoperable. It means any materialized view, streaming tables, or data assets that has been created in Python can be used in SQL in order to write pipeline code and vice versa. So today you understood how you can go ahead and use the new code editor in order to work with Lakeflow Spark Declarative Pipeline, and how Spark Declarative Pipelines has evolved from DLT and what are the new enhancements that has been made for it. Now, before I wrap up, it is important to understand that the core concepts of DLT still holds today, because that is the same declarative concept that has been used for Lakeflow Spark Declarative Pipeline, which in short form is known as Spark Declarative Pipeline or SDP. This was all for today. If you have liked this video, make sure to like and subscribe. Make sure to share this with your friends. See you in my next video. Till then, keep learning, keep growing, and keep sharing.